Bright Duty. Every student matters.
A pair of bullocks exert a force of 140 Newton. The force represented by capital F is given to me to be 140 Newton on a plough. The field being ploughed is 15-meter long. So, the distance is given to me represented by small s is 15 meter. How much work is done in ploughing the length of the field? Such a lengthy question with such a short and simple answer, I need to calculate the work done, which is quite simple, as I know that work done is the product of force and distance. All the values given to me, so I will just simply put in the values. Force is 140 Newton, multiplied by distance is 15 meters. Simply just multiplying it, I will get what? 2100 Newton meter or 2100 joule. This will be the work done by the pair of bullocks while ploughing this particular field, which is 15-meter long. Clear? Fine. Now, we are being given a few activities, and with reason we have to tell whether the work is done in doing these activities or not. So, there are few cases given to us. Now, the first thing, students, you need to remember is when we talked about work done, the formula was F into S. So, we need to keep this thing in mind, that work is done when both these conditions are fulfilled. What conditions we are talking about? We are talking about the force. There must be some force acting on an object, and displacement. There must be some displacement taking place in that particular object. When these two conditions are fulfilled, only then we say that work is done. So, the following activities that are being given to us in this question, let us see whether these activities are fulfilling our these two conditions or not. Right? Take the first case. Suma is swimming in a pond. Now, when Suma is swimming in the pond, she must be applying some force in the backward direction in the water, and because of action and reaction being equal and opposite, the water is applying an equal and opposite force, because of which Suma is able to go in the forward direction. So, keeping in view these two conditions, force is being acted upon and Suma is getting displaced from her actual original position. That is why we say that yes, work is being done in the case of Suma swimming in a pond. Second case, a donkey is carrying a load on its back. Now, the donkey is moving in the forward direction, carrying a load on its back, but the weight, the force is acting in the downward direction and the motion is in the forward direction. Since we know that whenever there is a perpendicular force acting, there is no work done. So, we will say that when a donkey is carrying a load on its back, actually donkey is not carrying out any work done. Got it? Please try to relate the reason on basis of which we are trying to explain whether the work is done or not. Next, a windmill is lifting water from a well. Now, when the water is being lifted from a well, the work is being done against gravity in the upward direction, right? So, therefore, we will say that work is being done. Alright. A green plant is carrying out photosynthesis. Now, while carrying photosynthesis, there is no displacement whatsoever in the plants. They will remain where they are even though they are carrying out the process of photosynthesis. So, in terms of physics, we will say that there is no work done by the green plants while they are doing this process of photosynthesis. Right? Next, an engine is pulling a train. Now, the engine is applying some force on the bogies, right? And there is some motion displacement in the bogies in the train. That is why we say that the engine is doing work in pulling out that particular train and all the bogies in that train. Next, the food grains are getting dried in the sun. Now, in order to reduce the moisture, we dry the food grains in the sun, right, so that the moisture evaporates. But even under the sun, when the food grains are kept, they are not going to move on their own. So there is no displacement whatsoever in the food grains. Therefore, what? No work is done. Next, a sailboat is moving due to wind energy. Now, the wind energy is applying some force on the sail. Sail is that cloth on which when wind strikes, it moves the wind in the direction of the sail. And since wind is applying energy, that means the force is being acted upon, and because the sailboat is moving, the second condition is also fulfilled, that is the displacement is there in the boat. Therefore, we can say that the work is done, right? Now, with reasons and with logics, you need to relate all these activities. You should not merely go with that guesswork. Then one case is yes, work is done, then no, then yes, then no, then yes, then no, then yes. It is just sheer coincidence that the examiner particularly has given this question in which there are alternate yes and alternate no, but this is not the basis of our answers. It should be strictly based on the logics and the reasons, and the reason behind finding out whether work is done or not is quite simple. There are two conditions which need to be fulfilled: the force and the displacement. Only then the work is done. Second thing, we need to remember that whenever the force is acting in the perpendicular direction of the motion, then we say that there is no work done. Got it? Let us see the next question. Now, in this question, what we are asked is, an object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and the final points of the path of object lie on the same horizontal line. Now, this is important. What does it mean? That actually there is no displacement, right? Because the initial and the final position of the object after being thrown and coming back is same. So, what is the work done by the force of gravity? Zero. Why? Because again, the work done is only considered when there is force as well as displacement. Since there is no displacement, so we say that no work will be done on this particular object. Let us see the next question. What is the work done by the force of gravity on a satellite moving round the earth? Now, we know that if a satellite, this is a satellite which is moving round the earth, then there is a centripetal force acting from the center which is perpendicular, and we have already studied that any object, any particular object in the universe, whether it is planets revolving around the sun or the satellites revolving around the planets, they always, when move in circular path, then their motion is tangent to the circle, right? This we have studied already. So, the force and the motion are in perpendicular to each other. Therefore, the work done by the force of gravity will be zero, because no work is done when the force is actually perpendicular to the motion. Clear? Let us see the next question. Can there be displacement of an object in the absence of any force acting on it? Think. Discuss this question with your friends and teacher. Now, when we just relate without thinking, the first spontaneous reaction that comes in our mind is simply no. That if no force is acting on it, how can an object show some displacement? But this is why the question is being asked. Let us see what exactly is force. What exactly is this force? Force is the product of mass and acceleration. This we have studied as per Newton's second law of motion. Now, we are saying that the value of force is zero. No force is acting. So the value of force becomes 0. So we are left with the equation m into a is equal to 0. Now we know that the mass of an object can never be 0. Therefore, a has to be 0. Now if a is equal to 0, what exactly does it signify? A, we know that it is acceleration. Is it positive acceleration or negative acceleration? It is a different aspect. But acceleration is change in velocity whenever the velocity of an object is changed, right? Acceleration 0 signifies two things. One thing is that the body is at rest. There is no acceleration. It was at rest and it is at rest. But there is a second possibility also. And that second possibility is that the body is moving with a constant speed. That means the initial and the final velocities of the body are same. And if the body is constantly, continuously moving, then there must be some displacement in that body. So now, after understanding this logic, we can say that yes, there can be displacement of an object even though there is no force acting on it, right? Fine. So you need to think a bit as to in depth what exactly the crux lying behind the question. Got it? Let us see the next question. A person holds a bundle of hay over his head for 30 minutes and gets tired. Has he done some work or not? No. Unfortunately, no. Even though the person is getting tired, maybe we can give him our full sympathies that he is carrying that particular load for such a long time, but in terms of physics, he has not done any work. This we have seen because the force of gravity is perpendicular to the motion, and in this case, he is just holding that bundle. He is not even showing any displacement. So the work done will be 0. Got it? Now, in each of the following, a force F is acting on an object on mass m. So this is an object of mass m. A force is acting. The direction of displacement is from west to east, shown by the longer arrow. This is the longer arrow which shows the direction of motion. Observe the diagrams carefully and state whether the work done by the force is negative, positive or 0. So we are given first case, second case and third case. Now we'll observe each and every case individually. In the first case, we see that the force is acting upward. The direction of motion is from west to east. So this is the perpendicular force acting on it, and whenever there is a perpendicular force, we know that the work done is 0. So in the first case, the work done will be 0. Let us see the second case. The force is acting and the motion of this particular object, this force and the motion, they are in the same direction. First of all, a force is acting, there is some motion or displacement in the object, that means work is done. Next comes the point that work done is positive when the motion or displacement is in the direction of force, negative when it is opposite. So in second case, we see that work is done, and because the motion of the force and displacement are same, therefore it will be positive work done. Let us see the third case. In third case, the direction of force and direction of motion are opposing each other. Therefore, we know that work is done because displacement is moved, displacement is produced with the help of force, but since they are in the opposite direction, therefore it will be a negative work done. Here, just you need to relate the direction of force and the direction of motion of the object. Got it? Now, let us see the next question. Sony says that the acceleration in an object could be 0 even when several forces are acting on it. Do you agree with her? Why? There are several forces acting on a particular object. Now, when there are more than one forces, then we categorize those forces into two things, whether it is a balanced force or an unbalanced force. This unbalanced force means that the object will be in motion, right? There will be some motion produced in the object, and if the motion is produced, then of course acceleration will be there, right? But when we are talking about balanced forces, right, balanced forces means these are the forces which actually nullify the effect because they are equal and opposite forces. So in that case the resultant force will be 0, and we know that based on Newton's second law of motion, F is equal to m into a force. We are saying that these are balanced forces, the resultant force will be 0. Therefore, placing the value of F to be 0, we get the equation to be m into a is equal to 0. Now, the mass of an object can never be 0, that we have already studied. So, that means the acceleration is 0. So, Sony is right when she says that acceleration of an object could be 0. Of course, it may be 0 even when several forces are acting on it. Clear? Let us see the next question. The mass of 10 kilogram is at a point A on a table. Let this be our particular table. So, this is point A. So, this object of 10 kilogram mass is kept at this point A. It is moved to a point B. Let this be a point B. If the line joining A and B is horizontal, we know this is horizontal and this is vertical, right? What is the work done on the object by the gravitational force? Now, we know that the gravitational force always acts downwards because it is due to the gravity, right? And the motion of this object is from A to B, alright, line joining this, which is perpendicular to that of force, and if it is perpendicular, then you already know that the work done will be 0. So, acceleration due to gravity has no work done on this particular object while it is being moved from point A to point B. Clear? So, these are a few questions based on work done. I hope you have understood the concept of work done. Please try to relate and study and do the numericals in order to get practice. Thank you so much.